All right, you're welcome back to Biology Lectures with Akere Let Philip. This question 3 in the past question solving series. So starch and cellulose are two important parts of polysaccharides. The following diagrams shows pardon me, please, shows part of a starch molecule and part of a cellulose molecule. So apparently this is the starch, this is cellulose. Explain the difference in the structure of the starch molecule and the cellulose molecules shown in the diagram above. Okay, well, all of these are monomers. Talking about these are glucose. But something caught my attention here, which are these and these. And that is a pointer. It says, explain the difference in structure. Good. Okay, let me start with starch. Starch molecules are formed from alpha glucose. Yeah, all of these are alpha glucose because they are hydrogen is here, their hydroxyl ion is here. It is not appearing like that anymore because it has lost the hydrogen in forming H2 condensation reaction, if you know what I mean. Because when you want to form monomers to form polymers, it's a condensation reaction which gives rise to water. Now, having established that part, that's for starch. Now, for cellulose is formed by beta glucose, which has its hydroxyl group inverted. Sorry, that spelling is not quite nice. Group inverted, or you can say flipped. I'm referring to this and this. Those are beta glucose. For this one, I just said starch molecules are formed from alpha glucose. Well, I don't. It's fine. I wanted to say formed from alpha glucose that has its hydroxyl group at the bottom, while the hydrogen group is at the top. This is what I'm saying. Right? Those are the hydroxyl group there. OH are there. H is here, so to say. So all of these are alpha glucose, and these ones are beta glucose. All right. Hope that's noted. All right. It says here, starch molecules and cellulose molecules have different functions in plant cells. Each molecule is adapted to its function for its functions. Explain one way in which starch molecules are adapted for their function in plant cells. All right, having established that, I think there are a lot of points here, really. Just 2 marks. Okay, let me just say this. Starch is made up of amylose and amylopectin. I'm going to explain this to you now. Permit me to till this the more. Amylose is forms a long chain through the 1,4 glycosidic bond, which allows it to fold up for storage. Yes. Now let me explain this part. Amylose is just like it has that straight chain, very long chain, and with that it's able to coil up and be stored in the plant's body. All right. Now the other part, which is amylopectin. Now, so amylopectin has branch chains, or let me say has branches formed by 1 to 6 glycosidic bonds. This allows it to break off easily, thereby releasing energy. Please pardon my handwriting. I'm just trying to rush up, but you can just listen to what I'm saying, really. So because it is branch chain, it goes like that, it has branches. So those branches can easily break off, so to say. All right. Now, the other one is explain how cellulose molecules are adapted for their function in plants. Okay, 3 marks. Okay, here we can say it is formed by beta glucose. Okay, it forms several parallel lines or parallel polymers, so to say. Parallel polymers. All right. These parallel polymers are joined by hydrogen bonds. The hydrogen bonds makes them soft and compact. The cellulose, let me put this in. These help support the cell wall of plants, preventing it from bursting in hypotonic solution. That means a dilute solution. Now, I've said a lot of things here. The point I actually wrote here is more than 3 points, but I wrote all of that so that you can be able to have more choices to pick from. All right. So these are the point. Let me explain something to you here. It says it is formed by several. So it goes like this, like that. Just try and get what I'm trying to do. Parallel lines, like parallel polymers, like that. Now the funny thing is that each of those polymers are then joined like that by hydrogen bonds. So these hydrogen bonds, even though it seems weak, but when it becomes repeated and it's mass, it makes this cellulose tough, like really, really tough. So they are joined like that, but they are now joined by hydrogen bonds. So this is what joins them here is glycosidic bond. The normal glycosidic bond, you know. Then, but the parallel chains are joined to each other by hydrogen bonds. So these bonds here are called hydrogen bonds. Those are I circled. All right, hope that made sense.